right, so ladies and gentlemen, in this hour of GroupBy, Daniel Hutmacher will be talking about not just polish, how good code also runs faster. So take it away, Daniel.
And there goes the adrenaline. So hi, everyone. I already have a heart rate of 150 or something. My Apple Watch is telling me, like, you're having a cardiac arrest. I'm fine, totally. So for those of you who don't know me, I run the blog SQLSunday.com, which was sheer convenience. SQLSaturday.com was taken when I started the blog, and I didn't even know what it was. Today, I'm going to talk about how neat code, pretty code, can sometimes run even better than elaborate, complicated code, because the common truth of sorts, and even I say this, is that the simple code can often be the one that isn't very efficient, and when you optimize it for all sorts of purposes and indexes, the code tends to become a little more complex. So I spent a couple of days harvesting up some really terribly bad queries that I've seen at clients and trying to anonymize them and run them in the Stack Overflow database. If you don't know about the Stack Overflow database, Brent has prepared a huge database. In my sense, huge. It's like 100 gigs or something.
Yeah, it's up to like 350 now too.
All right, mine's old, so mine's just 100 gigs, and I ran database compression on everything. And so this gives you the chance to run some seriously heavy queries and experiment with indexes and what makes a difference really in terms of performance. So in my abstract, I wrote no PowerPoint, only T-SQL, and this is one of 2 PowerPoint slides. That's it. So if there are any questions or if there's anything you see, this is a very ad hoc session. I have a couple of scripts I'm going to run through, so stop me anytime, ask questions, and we'll see where it goes. See how many scripts we run through before our time runs out. So is it like an hour or 1.5?
Yeah,
or what?
Yeah, like an hour. Yeah, I think the next one starts at 9:15.
Cool. So this is my management studio, and I have a demo server it's a pretty beefy Azure machine. I ran out of CPU allowance. They wouldn't let me have more cores without actually opening a support ticket. And I thought of this morning, but it has something like 8 cores and 50 gigs of RAM. You can see that this query here has been running for 23 minutes odd, is still running, and I'm pretty confident that by the time this session is over, this query will still be running. So I'll just leave that running here, and maybe you can hear my laptop as well. So I'm going to run through a couple of patterns and see. Some of this is going to look like a hobo stayed in it for 2 years or something and didn't clean up after him. This is actually stuff. I didn't make this shit up. I see this at clients, and even some, let's call them senior BI professionals, write these types of queries. And so they just hurt my eyes, and I always fix them instead of doing what clients actually pay me to do. But on the plus side, you know, their servers run faster when I'm done. So let's start off with some date functions. Surprisingly, a lot of T-SQL workers, a lot of people who work in T-SQL don't really know how to work with dates. And I'm just going to show you some simple examples of, is the text readable? Is it too small?
Yeah. No, I think it's okay. Yeah.
So here's a pattern that I find quite often. And if you look at it, it's like, what does this code actually do? And you look at it and you think, okay, how many dates difference from 0 to the date is it? And then you add those days back to 0. And what you get is that you've just rounded off the numbers, the date. Oh. So you get the date part instead of the full date time with hour, minute, and seconds. And there's a much simpler way to do this. You can just cast it as a date. That's it. It's that simple. this is much more readable. So if you're thinking, is there a function that will round off the time parts of the date time? Just cast it to date. Previously on SQL Server 2000, I think you needed to cast it to float, floor, and then cast to date time back before you had a data type. So,
that date add is terrible. Oh my
yeah,
God.
I see this everywhere. I just thought it was the one person, and I kept seeing it in different clients, different code. It's you look at it, your brain can't figure out what it actually does. On the plus side, I will say, when I experimented, you can change the day thing to pretty much anything. And here it comes into its own right. So you can round to the nearest hour, for instance. It's still not readable, but it serves some kind of purpose, I suppose. Here's another one that I found. Say you want to convert a date to the first day of the month. So you could, I'm saying could, you could convert the date column to a character with 8-character length. You specify using the convert function, you can specify the format so you're sure that it'll always be the same. Then you truncate off the 6 first characters, which is the year and the month, and you add 0, 1. Now we're working with the varchar, right? And then you convert it all back to date. And that looks something like this. So here we have the year and month and the first for each day.
I have totally.
I guess you could, yeah, I guess you could look at this and make sense of what it does, but wouldn't it just be easier to use the date from parts function, which is new from SQL Server 2012? You just feed it a year and a month and a 1. That does exactly the same thing.
Oh, that's
so
cool.
It's easier to read. And on the same vein, last day of the month, this gets even messier, because what we do, reading from the inside and out, we convert to a character, truncate off the last 2, so we have year, month, and then we add a 0, 1. Turn it back into a date, we add a month, and then we subtract 1 day from that. So we have the first day of the next month, and you subtract 1 day, and what you get is the last day of the current month, right? Or you could use the EO month function, which is also new, I'm saying, for SQL Server 2012. So if you're on 2008 R2, I don't think EO month can work.
But at the same time, the good part of that, like 2008 and 2008 R2 are out of support next year anyway. So it's one of those times where
now so no one's working with them anymore. None of my clients are totally, I swear. All right. And on the same, on the same note, if you can use EO month to calculate the last day of the month, you can also use day parenthesis EO month to get how many days in the current month there are. So I saw this one client who had a distribution function where he has transactions on a date in a month, and he wants to split those transactions into even-sized rows, 1 for every day of the month. And so for March, that would mean dividing it by 31. And the calculation was just mind-blowing. It involved something like this. Yeah, let's not.
Yeah, that's awesome.
So that's for the date functions. I'm just gonna blow right through all these scripts and just run until someone stops me or asks me a question. Just let me know if there's anything.
There's a good one up over in the Slack. That's Mick says there's a related question on Database Administrator Stack Exchange. He says, when I cast stuff to dates, is it sargeable? So should I use it inside the where clause in order to get index utilization or not? Do I run into problems with it?
I would generally say whenever you cast something, I think you're screwed. I haven't tried it. I think I've tried it, and I think you're screwed, basically.
Yeah. If it's
with
in the
regards to sargability.
Yeah.
So, but readable code and all.
Yeah, it's a different problem.
Yeah. And next up, again, you're not going to believe this stuff is real, but this is actually code that I've taken from a client. It's not that code, but in the same vein. So you have two common table expressions. You have the comments and badges. And on Stack Overflow, there's a badge called commentator. And you get that badge if you have 10 comments or more on posts. So you can select from comments, group by a user having more than 10 comments. And you can select the users that are commentators. And now I want to full join these two. So I want all the users with 10 or more comments, and I want all the users with the commentator badge. And I want to see where there's a difference. So the obvious solution to this would be to do select from comments, left join badges, right? Mm-hmm. And then union it with badges where the user isn't in comments, right?
How did they, I mean, like, I would like to see a diagram of that thought process.
Yeah, I mean, I guess, and my reasoning here is I think this person didn't know how a full join works, because full joins come with caveats as well, because you can really easily screw one up with if you put the where clause in the wrong place or things like that. So, but
or just read advice somewhere once that full joins are bad.
Yeah, because it said so on the internet. and this is an ugly and expensive query, and you don't want to go there. So instead, you can just full join. Instead of left join, you can full join, and that means we get all the rows from comments, all the rows from badges, and matching when they do, and otherwise you just get null values. I'm not even sure if this will run if I'm maxing all my egg cores. Anyway. Oh, and I love the new live query statistics thing. So if any one of you is working out there with live query statistics, it's a fun gimmick. It's really cool to show off. 1 out of 10 times Management Studio will crash on you. That's they fixed a lot of problems in Management Studio 17.4, I think. They still have a few issues to work on. If you're working for Microsoft and you want to repro on a query that crashes the live query statistics, let me know.
You should put that in at that feedback site.
Yeah, I'm going to do that someday. So you can see how it counts up the rows and adds up and
shows your progress live.
So
it shows where estimates are wrong, you know, when you shows 200% done with something.
Exactly. Anyway. So that's for the, I don't know what to call this. Is this a fake full join or an ugly full join or, yeah.
Wow.
Next up, cross-apply. So those of us who work in business intelligence, it's quite often where we want to unpivot a table. Is it unpivot? Yeah, it's unpivot. So if you have 3 or 4 measures and columns, you want to add a dimension called measure type or metric or whatever, and you want to unpivot the data so you have 1 row for each dimensional section and combination of metric. One way to do that is just to query the table multiple times so you can read the data. In this case, I'm splitting up the tags. Yeah.
Cross-apply. Wow.
So this is basically I'm splitting the tags just to give SQL Server something to do, because who wants queries to go fast, right?
Wow.
And so we have a metric called answers, and here we sum answer count, and we have a metric called comments, and we do a sum of comment count. And while this query may be readable, it's not pretty really.
Oh, that's cool.
When I timed it, it took 49 seconds to run. If we look at the execution plan, It's
This is
a
going to be
number of
terrible.
concatenations, and we basically just seek or scan the index once for every query.
Mhm.
So there's a lot of IOs going on here.
Not a small
Instead,
table.
not a small table. It's a very, very large table. Instead, you could just scan the table once. This is our split thing. And then you could cross-apply the values tag. I just learned a couple of years ago, this is very recent knowledge for me, that you can add a comma here to have multiple rows in a values clause. This is
That you can build your own table. Yeah, build your own table on the fly.
Exactly. Except with cross-apply, you can reference columns that aren't hard-coded. So I'm referencing columns in the posts table. So for every one row that comes out of posts, I create 1, 2, 3, 4, 5 rows in my cross-apply.
That's sweet.
And believe it or not, this query looks a whole lot simpler. You have a single scan, and then the nested loop is once for every row that you get out of the posts table, you perform the string split, and then once for every one of those, you split it into, whoa, so much data. You split it into those 5 rows, and then lots of aggregation happens and everything.
That's awesome.
Disappointingly, and I was totally betting on that this query was going to be so much faster. I mean, in theory, it's a fifth of the number of reads from the table, unless the aggregates screw this up. But in theory, it should be like 5 times as fast, and mostly it is, but it wasn't for me. So I have a theory, and what I came up with was, if I did this first, if I did the split on the tag, so I get 1 row for each tag first, and then aggregate these 5 columns separately, put them in a subtable, and then do the cross-apply thing. So I aggregate first and then 5-tuple, pentuple, the data amounts. That would give me a considerable performance boost. So it went from 2.5 minutes down to 25 seconds. And 25 seconds is technically faster than 50 seconds, but yeah, it's a Pepsi challenge if you think this or this query is more readable. So yeah.
Nice. Now, how long did it take you as you were experimenting through these to get from that first query to the third query? Like hours, I would guess.
Yeah. Not minutes.
Yeah.
I actually did try unpivoting and adding a small data type as I could, because this data type expands into this is a varchar something, and it takes up a lot of bytes. So not only do you get 5 times the amount of rows, if you look at the query plan here.
Oh, wow.
So if you imagine that this is 130 megs, this is 464 gigabytes. I'm not saying anything about the estimates, but just in case it's 464 gigabytes. And this is 2,314 gigabytes. So if instead you would just put a 1, a 2, a 3, a 4, and a 5 here, that would be an integer, which is 4 bytes. Or if you put 0x1, it's a binary 1, which is a single byte. And that really improved performance for me. I got it down to like a minute or something.
Wow.
But by completely eliminating the whole pivot thing before you've had a chance to do the aggregation, that was what got us down to 25 seconds.
Wow.
So yeah, I have too much spare time. I took the entire week off basically to just build this presentation.
Jeez.
That's it. See, no boss. No one's asking you, where have you been all week? Why aren't you at the office?
You get to learn anything you want to, get to build anything you want to. Yeah.
You guys should all totally be your own businesses. So in next seminar, we're going to talk about how to get your business running. Which is
why work 40 hours a week for someone else when you can work 80 hours a week for yourself?
Exactly. Oh, this one's fun. Can you tell what this does?
Why would someone do a
not-
count star from a subquery?
Yeah, okay, so the count star is just so I don't get 2 million rows back into my management screen. This is actually the query. but we all recognize this pattern, right?
Yes.
So
yes.
where ID is less than max ID. So for each combination of user and badge, I just want to keep the most recent badge. So you could actually type equals here or something. It's the same principle. The problem here is because you have the equality here is fine, but because you have the less than and the order by here, this all turns into a loop join, a nested loop. And for those of you who are familiar with the Stack Exchange database or Stack Overflow database, badges has something like
a lot.
10 million rows, I'm guessing. So we're going to make an index seek 10 million times against badges here, which is probably not a good idea. A sorted index seek, by the way. So this query performs surprisingly well given how hopeless it is. But there's a much better way to write this by using a window function. So essentially, a window function like lead looks for a cell value or an expression in the next row. I'm telling it to look for this expression 1 row forward. And if it doesn't find this expression, if the next row doesn't exist, it just returns a 1. So if I partition this window function by user ID and name of the badge, and just order it by date and ID as a tiebreaker, I will get a 0 if there is a next row, and a 1 if this was the last row for this user ID and name. So maybe the syntax isn't entirely intuitive if this is the first time you're seeing this kind of construct, but I use this all the time, so because I look at it all the time, I think it's perfectly normal. And I can see people opening up their Scotch bottles right now. So what we can do here is, oh yeah, did we look at the query plan here? Yeah, exactly. So this was the one with the nested loops, where it does a loop join as an index seek on badges for every one of those 10 million rows here. If we look at the query down here, we just scan through all the badges. We sort them obviously by our partitioning expression and our ordering expression. So if you want to optimize this query, you would change the index on badges to sort to match these conditions, and it will be super, super fast. At this point, it's just regular fast. And the segment and sequence project here, those are the window function, the lead and the lead function. And I honestly can't say why we have a segment and sequence project and then a sequence segment and window spool. In my mind, it should be just a segment and a window spool, but the point is the same. So we're ordering the output from badges, which we're scanning just once. So we're starting at the beginning of the table and just scanning right through the everything. And yeah, so this query up here goes for 30 seconds or something. And this query down here went for 10 seconds when I tried it.
That's nice. So
I'm running my terrible query in the background. We'll see if, oh, let's try it. Live query plan.
And when this is in all supported versions of SQL Server, I think this even goes back to 2008, or was this 2012 that that came out in?
The window functions?
Yeah.
I think that's, I think you got window functions in 2008, and you got ordered window functions, which I suppose Microsoft calls something else, analytical or something. Those appeared in 2012. So lead and lag, I think, were in 2008, but I'm not sure.
Yeah, so this ran 25 seconds, even with the intensive load going in the background. That's fantastic.
Yeah. Such a terrible load. Right. No questions, right?
No, you're good.
Your
One person,
grammar
let me.
fell.
Let's see, who was it? I'm going to look back over. Todd says, I'm literally staring at the code back with the date ads. He said, I'm staring at the code back with similar bad date ads. That bit there made the whole webinar worth it for me. Yeah, so thumbs up there.
So here's another one. A client of mine had a table with, it wasn't an ID column, it was a kind of a accounting period column. But the thing was, they made a varchar of the accounting period column. No, sorry, this is wrong. Same procedure, wrong chapter. Where am I going with this? Yes, we have a procedure, right? Let's stay with the BI thing here. We have an imaginary metric on Stack Overflow where you're rated in accordance to how many questions you've answered divided by the number of questions you've asked. So we'll just call a variable ratio and we'll select the number of questions, no, it's number of answers, and divide it by the number of questions. So far, all good. We'll just select that ratio. But bad things happen, so we'll just put all this in a try-catch block. And if you haven't seen a try-catch in SQL Server, it's pretty much the same thing as in regular procedural programming, except you can't use finally. There's no finally. And I never got the point of finally anyway. So if something goes wrong within these two try blocks, or begin and end try, the code executes the catch statement here, which in this case returns a null value to the caller. And then throw is like raise error, but throw without an argument rethrows the error that happened in the try statement here. So if something happens in try and you catch it, there's no error message because nothing happens. You literally caught the error. And therefore, you might want to use throw just like that without an argument to rethrow the error. So if someone else is calling this stored procedure, they should know about that something went wrong. You just wanted the chance to clean something up before you actually rethrew that error. So I'm going to create the procedure, and I have a demo user called something, and we can see that this user has a ratio of 3.0. And that means that this user has answered 3 times as many questions as he or she has actually asked, which is a nice ratio. Let's say this matters for some reason. Let's try a different user. Oh, and have you guys seen the with result sets?
No.
This was fairly new to me. So if you execute a procedure, I'll just run it like this. And I did select ratio, and I didn't specify a column name or anything. If I add with result sets, I can say anything that comes out of this stored procedure follows this column naming and this data type.
So you
if
could
I
even
run
change.
it with, yeah.
Oh, nice. Change your column names that come out. That's pretty spiffy.
You still can't put it in a view, but it's useful for stored procedures where you want to change the column names, I suppose, in, I don't know, an SSIS job or something. So if we run the same stored procedure on this user, we get a null, which is, okay, it's a null. But what's really going on here? If we just run it without the with result sets, anyone spot it?
Throw. The name of the column name is throw.
Yeah, because I didn't put a semicolon here. I might as well have select null as throw, right?
Oh, wow.
Fine. So at the risk of sounding a bit like Aaron Bertrand, please put semicolons after each statement, because if I just put a semicolon after the null here, run this statement again, I get the ratio null and divide by 0 encountered. So you can actually screw things up unintentionally by leaving semicolons out. And throw made its debut in SQL Server 2008, I think.
I think you're right.
And I'm betting they're not going to change any of this in a sense that breaks code, but rather add more features like these. And I'm also thinking about common table expressions that starts with. So, oh, Erland thinks you should always put a semicolon before throw. It's an ugly pattern. Yes, it works, but I don't think you should. So I'm betting that even if they don't add anything new, it makes code prettier, and you can avoid dumb accidental mistakes like these. So write pretty code, put semicolons on the end of everything. I absolutely adore that they brought the try-catch block to T-SQL. That has saved my ass on countless occasions. Me too. And the rethrow is really, really pretty. It's a handful if you're like some of my clients building stored procedures that call stored procedures that call stored procedures that call stored procedures, and you nest everything, and sometimes they even declare a temp table in the top procedure and then build a whole stack that is dependent on that temp table to exist, which makes it hopeless to debug. But yeah, throwing and rethrowing, it's a handful. So design it correctly from the beginning on, and you'll be fine.
Yeah, make sure your code never throws an error, never has an error, and then you're good. How hard can it be?
It's my kind of code, actually. My kind of code. I like it. Right. Same procedure. I've added all the semicolons. You will notice that you can't add a semicolon after end try. I figured this out the hard way. Let's try this. Nope, incorrect syntax near semicolon. Bonus tip, did you know you can double click the error message and go to the row where the error occurred? So apparently the end try begin catch is a single statement in T-SQL.
Oh, okay.
Because if you add a semicolon here, it won't work.
Yeah. Oh, okay.
That makes perfect sense. Oh, did I create that in master? Here we go. So I've created the same procedure with the semicolons and everything. I've suffixed _problem because I'm querying a different table. So I've made a copy of the posts table that I call problem posts. And I did it in a database that I call Stack Overflow Mini, which contains only a fraction of the number of rows. For this one, I'm going to turn on statistics because I'm not going to be sitting here with a stopwatch timing millisecond performance. So if I run the regular query first, this one does 8 logical reads, 2 scans, which makes sense. So 1 scan for this, 1 scan for this. It seeks because post type ID is the first column in the index, user in ID is the second column. So if we look at the query plan, this is a really, really efficient query plan.
It looks big, but it's fast.
This is actually the magic. So we do 1 index seek on answers, 1 on questions, aggregate them because this is the count. Yeah, it's the count of how many questions and answers you have. And then we just, because they're 1 row each here, 1 row there, 1 row there, divide one by the other and select the output. This is a super fast query. What happens if we do the same thing with our problem query, where I've changed the data type on post type ID to a car1? Because someone figured out that post type ID is always a single digit value, right? Why waste an integer which takes 4 bytes if you can have a single digit length character which takes 1 byte to store, right? So if we look at the question, look at the table.
Who does this?
Oh. So we have post type ID character 1. This is pretty common, I think. Or it's just that I work in Sweden. I don't know. We have
Swedes are
polar
very
bears too.
efficient, maybe. Yeah.
We have polar bears too. Praise the Lord. Now, if I run this query, what's going on here? It's 3 seconds. It's 4 seconds. And that's because we did 96,000 logical reads as opposed to just 4 before. We did 18 scan counts, and that's probably because of parallelism. So we ran somewhere in the range of 4 seconds to complete the same question, same query on different tables. Now, those of you who know about sorgability already know the answer to this one. If you do an implicit conversion between a character and an integer, the integer wins. You always convert the varchar value or the char value to an integer. And in this case, this means you can't perform an index seek because you have to try every value of every row in the table and see, is this 1? Does this convert to 1? Does this convert to 1? Does this convert to 1? And that takes a long time in a big table.
The character wins and we all lose. Yeah.
If you run into this in the real world, rather than perhaps rebuilding post type ID and crashing every application, every dev ever built, you can just add apostrophes here.
And Hiram asks too, when you get a second, show how you quickly pulled up the table definition.
Oh, so standard in SQL Server, you can press Alt F1, and Alt F1 will run a procedure, a stored procedure called sp_help. All this stuff is out of the box. It comes with Management Studio and SQL Server, just the way you're used to. I built a replacement for this called sp_control3. So this is a stored procedure that works pretty much like sp_help, but it gives more detail. So I can copy index definitions, and it says nvarchar 100 instead of, which is it? See, the nvarchar here has a length of 200 and says computed no. And so I found this stuff pretty hard to copy paste when I wanted to recreate tables. So if you're interested in this sp_control3 stored procedure, it's on my blog, sqlsunday.com. Look for the downloads. But this is my homemade tool because I think sp_help wasn't good enough. So you can just copy all of this, put it in a new window, and you have the create table syntax ready to go.
Spiffy.
Yeah. Mm-hmm. I never use other people's tools, ever. I rebuild everything from scratch. This is my personality. So I added quotes. So this is now a char/varchar/ I don't care. But the point is, we don't have any implicit conversions anymore. And when I look at the query plan now, there's a seek, an index seek here, and it doesn't even go parallel. So it finishes in 8 milliseconds. That's good enough, considering it had to build a plan. 8 logical reads, 2 scan counts, just the way we wanted it. So for the love of all that is holy, avoid implicit data type conversions. I'm okay with having funky data types. I'm even okay with having transaction periods in a char column or an int column or whatever floats your goat. But avoid the implicit conversions because they will screw up your sorgability, which is a killer when you have a large table. Yay, that's the one.
Yeah.
All right, so this one's still running. It's 1 hour now. I started a little bit ahead of the show, so it's this thing isn't going anywhere. If we look at the CPU, it's still maxing. The memory is still maxed out. This query is going absolutely nowhere. I'm going to stop it here. And this is the query that we were looking at. I put DNF here. And what we're trying to accomplish is for each user, I want to see if they have asked a question, meaning post type ID 1, that hasn't been answered within 24 hours. It's not really a trivial question, So I want to see how many questions each user has asked that hasn't been answered within 24 hours. So I'm basically looking for post type ID 1 is the question, and the ID of the question is not in parent ID of any answer, where creation date is less or equal than 24 hours later than creation date. So this is probably a standard report that some manager wanted you to write. Or the developer just showed up at your doorstep and said, my query is slow, and they drank all your Snapple and left. So if we look at this query, here's the wrong database. Thank God for master. Here's what our query looks like, which is strange, right? Because we have a merge join between users and posts, which is fine. Am I on the right place here? Yes. But the problem here is that I'm doing a nested loop join on the post. And this post here, you can see the scalar operator 2 at the bottom. That's the questions, the answers, sorry. So when we look for answers, we use a nested loop join. And I'm going to be completely honest, the query plan isn't exactly the one that I prepared. I was going to demonstrate another problem, which is if you look at the table dbo.posts, the parent ID column points from the answer back to the question it actually answers. And you'll notice that this column is nullable. You can put a null value in parent ID. So if you write a query where something not in a nullable column, SQL Server has to actually verify if there is a single null value anywhere. That is a, what do you call it, a false result. So X in Y, where Y is null, is always false, not in. Yeah. So you're just making it harder for SQL Server because it has to do this extra check. And it used to be that, let me see if I can fix this. Look away, kids. No, this is not. It should have done a check for null values, but I'll leave it at that. Anyway, if you suspect that this is a null column, if you do not in and you select the nullable column, you can just add and parent ID is not null. That'll simplify it. I mean, yeah, sure. The obvious choice, if you know that there are no null columns, no null values, which is the case here, because when you don't have a parent ID, the developers of this database put a 0 in. So in this case, I know from experience or because I built the web app or whatever, that there will never be a null value. It's just an incorrect definition of the column. But say you can't change the definition. You can just tell it that parent ID is not null. And if we run this query, boop, 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 boop. Let's see what it does to the CPUs. Oh yeah, we're rocking.
I understand. It looks like it's done. And it's especially useful in, third-party databases where you can't control the schema.
Yeah. So this is the same query that ran for the entire session for around an hour and didn't finish. And basically what it's doing right now is just hammering my local CPU and my bandwidth because it's like a million rows, but it returned instantly. Right?
Nice.
I blew it up. Sorry. Yeah. So to recap, if you use not in with a nullable column, it has to check if any of the values is null. And that check is fine and dandy if it's just once, but because we did a less or equal than, it has to do this check for every single time, which really screws it up for us.
Nicholas says over in the Q&A, that's cool, dang you.
Thank you. So at 46 minutes, that pretty much wraps up my session. I'm open for questions for another 14 minutes or whatever. Also, I would like to please leave feedback. I created a Google form just for you, dear viewer. That's you. Please, because I'm booked for this session 2 more times this autumn, and I'd like to get it just perfect. So let me know how it went.
So let's see. CT, a very nice job too. Excellent. I love the man. Some of the date stuff is just awesome. On that last query, a CT asks, what happens if we use not exists instead of is not in?
Interesting. Where? Let's make a copy of this one. This stuff always gets me. Where not exists, and p.id equals parent ID, right?
I think you're right.
Null there or something. Smooth.
It looks good. It looks good.
Yeah, looks decent enough. Because let's look at the original query. The cost of the original query was, well, I'm not going to go there. It's like I have to count the zeros. 251 million query bucks, as opposed to my suggestion here with the is not null, which clocked in at 299, and this one is a promising 327.
Hey, not bad.
Let's see how it goes.
Fingers crossed. Hey, I like it.
You'll see my CPU stack down there. It's working very hard right now. Yeah, so I think they're about even.
Nice. And then Vossel says,
because implicitly, if I'm making an equal to compare to a nullable column, that automatically excludes all the null values. So you cannot join something and expect null values to come out. So this problem is really isolated to not in. You were saying, sorry.
No, the next question was Vossel asks, could we split the post table into 2 different tables, questions and answers? Then the questions don't need parent ID and the answers will have a parent ID as not nullable. I would say, do a select from post types. Do you have the post types table?
Yeah. I think post types is 1 for question and 2 for answer.
Yeah, so the problem is if you wanted to split this up into different types, you'd end up building like 7, 8 different tables, and then the number of tables just keeps growing as soon as, and wouldn't it be nice if you just had 1 table for everything? No, oh, okay, yes.
But I mean, technically, I think for posts, that's, I think parent ID is 0. So in practice, they're using 0 as a fake null here. So we know that there are never any null values. It's just nullable by definition because that's how it was created once back in the 2000s.
It also helps comments a little bit easier. So you can leave comments on either a question or an answer. And so there's just 1 comments table with a post ID attached to it that just joins to the post table. Yeah, there's pros and cons of all those.
Pretty sure one of our viewers designed this database, so I'm not just going to keep it down a little.
When the original one started, I think it was Jeff Atwood and Sam Saffron, I think, or Jeff Dalgas who designed it. And the thing that always blows people away is looking at the tags column. So the tags column on there in the output, you can tag at Stack Overflow. You can tag questions with up to 5 tags. So C#, .NET, date, time, etc. And you look at that 1 field with 5 tags in it, and the database people in the house are scratching their skin going, oh, this should never happen. You know, and that's exactly how it went live. You know, databases aren't perfect when they first go live.
Yeah, but you get better performance, actually. Well, no, maybe you don't. If you want to search by tag, no, you don't.
No, it was terrible. That was the reason why we ended up having to separate out the tags into a separate table. Jeff was like, so, and people immediately look at that and go, oh, can't you use full text search to find any query with, say, the, WinForms tag? But then look at those tags and full text doesn't work, like C# or .NET. You know, those full text just doesn't work as well there. Plus there are tags with versions like or CSS3, you know, .NET 3.5. Yeah, it's just tough.
Totally.
All right. Well, lots of people saying thank you. Great presentation over in the chat. Really nice job.